Hello everyone. This is Albert Nixon, Assistant Professor, Department of Chemistry, St.Joseph's College of Arts and Science, Autonomous, Cuddalore. The topic we are going to discuss about periodic properties and its classifications. This is a modern periodic table, right? So it contains S black and B black and D black and F black. Classification of elements. With the discovery of large number of electrons, it became difficult to study the elements individually. So classification of elements was done to make the study easier. Mendeleev periodic table. Mendeleev's periodic table is based upon Mendeleev's periodic law, which states the physical and chemical properties of elements are a periodic function of their atomic masses. At the time Mendeleev, only 63 elements were known. This periodic table is divided into 7 horizontal rows are called periods and 8 vertical columns are called groups. The zero group was added later on in the modified Mendeleev periodic table. Some importance of Mendeleev's periodic tables. The systematic study of elements. The second one is prediction of new elements and their properties. He left space for the elements yet to be discovered. Atomic masses, corrections of doubtful elements on the basis of their expected positions and properties. Defects and demerits of Mendeleev's periodic table. These are the points does not discussed or does not clarified by Mendeleev. The first one is position of the hydrogen in the periodic table. Second one is position of the isotopes. As Mendeleev's classification is based on atomic weight, isotope would have to be placed in different positions due to their different atomic weights. If we taken proton, neutron and deuterium, they have different positions. And third one is anomalous position of some elements. Then fourth one is position of the lanthanides and actinides. So lanthanides, actinides were not placed in the main table. Some structural feature of a long form of periodic table. The long form of periodic table called Bohr's periodic table. There are 8 groups and 7 periods in this periodic table. The horizontal rows are called periods and vertical columns are called groups. So it contains 7 periods and 18 groups. The first period, hydrogen to helium, contains 2 elements. Is the first and shortest period. The second period is lithium to neon. The third period is sodium to argon, contain 8 elements, both the second and third periods. Then fourth period contains potassium to krypton. In the fifth period, rubidium to xenon contains 18 elements each. These are long periods. Then sixth periods, cesium to radon consists of 32 elements. And seventh period, starting with the francium, is incomplete and consists of 19 elements. Some characteristics of S black elements. They are soft metal and low melting boiling point. They have low ionization enthalpy and are highly electropositive nature. They lose the valence electron readily to form +1 and +2 state. If it is an alkali metal, it ready to form +1 state. If it is an alkaline earth metal, +2 state is. They are very reactive metals. The metallic character and reactivity increases as we move down the group because of high reactivity. They are never found in pure nature. The compounds of S black elements, with the exception of beryllium, are predominantly ionic in nature. Most of the metal of this blank import characteristics of color to flame, exhibiting various colors. They are strong reducing agent. So usually the alkali metals are used as strong reducing agents: lithium aluminum hydride, sodium borohydride, right? Lithium, so cyanoborohydrate, these are all strong reducing agent. All are good conductors of heat and electricity. The second one is B black elements. Elements in which the last electron enter any one of the three p orbitals of their respective outermost shell, called B black elements. A p subshell has three degenerate p orbitals, each one of which can accommodate two electrons. There are six groups of B black elements. These are 13th, 14th group, 15th, 16th, 17th, and finally 18th group. The atoms of elements belonging to this group receive the last electron in 2p, 3p, 4p, 5p, 6p, vice versa. If they are moving down the group, if it, in boron 2p, aluminum 3p, gallium, indium, thallium, it ends up 6p. Some characteristics of B black elements. So B black elements include both metals and non-metals, but the number of non-metal is higher than that of metals. The metallic character is increases. The second one is ionization enthalpy are relatively higher as compared to these of S black elements. They mostly form covalent compounds. Some of them show more than +1 oxidation states of compounds. Their oxidizing character increases from left to right. Next, D black elements. Elements in which the last electron enters any one of the 5d orbitals of their respective penultimate shell are called D black elements. Since a D subshell have 5 orbitals, each one of can accommodate 2 electrons. Therefore, in all there are 10 vertical columns comprising 10 groups of D black elements, namely 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. General characteristics of D black elements. They are hard, malleable, ductile metal with high melting and boiling points. They are good conductors of heat and electricity. Their ionization enthalpy of between S and B elements. They show variable oxidation states. It is an most important aspects, right? It shows variable oxidation states, or otherwise called variable valency. They form both ionic and covalent compounds. Their compounds are generally colored and paramagnetic in nature. Most of the transition metals such as vanadium, chromium, manganese, iron, cobalt, nickel, copper, their compounds are usually as a catalyst, and the second transition, third transition also. Most of the transition metals form alloy. Zinc, cadmium, mercury, which have the NS electronic configurations, do not show most of the properties of transition metals. Then finally, F black elements. The elements in which differentiating electron enter in the F orbitals called F black elements. These elements are also called inner transition elements because they form a transition series within the transition elements. It contains two series. One is lanthanide series, elements following lanthanum to lutetium. So whereas 4f orbitals generally filled is known as lanthanide series. Then actinide series, actinium to lawrencium, where the 5f orbitals are gradually filled, is known as actinide series. Some characteristics of F black elements. They are heavy metals. They have high melting and boiling points. They show variable oxidation states. Their compounds are generally colored. They have high tendency to form complexes. Most of the elements of actinide series is radioactive. These are the some general properties of periodic table. Size of the atoms and ions, ionization energy, electron affinity, electronegativity. These are shown in the here I represented the ionization energy, electronegativity, affinity. So all those things. So thank you for your patient listening.